Polly the Polynomial Penguin, talking to you about multiplying monomials and polynomials. Here's a question. What's a penguin's favorite lunch food? Iceburgers!
First thing we're going to talk about is multiplying monomials. So when multiplying two monomials together, you're going to multiply the coefficients together. Then you're going to add the exponents of the like bases. So here's the deal. Because this is all multiplication, right? You have one monomial here multiplied by another monomial here. And all of it is multiplication. There's no plus or minus signs. Because of that, you could actually use the commutative property of multiplication, which says because it's all multiplication, it doesn't matter which order you multiply these in. So what I'm going to do is I'm going to rearrange this so it makes more sense. I'm going to take the 3 and multiply it to the 5 in the front. That way we see that these two things have to be multiplied together. I'm going to put the x's next to each other. So the x to the first, I'm going to multiply to the x to the second. That way they're next to each other. And then the y to the fifth, I'm going to multiply by the y to the third. Those are now next to each other. Now you can see all you have to do to simplify this is do 3 times 5, that gives you 15. X to the first times x to the second gives you x to the third. And then y to the fifth times y to the third, you add those exponents together, you get y to the eighth.
What's a penguin's favorite part of a cupcake? The icing! DeLazzer!
Example 1 says simplify each product. So here we're multiplying these two monomials. So first thing we do, multiply the coefficients out front together. So 100 times -4. And then we're going to multiply the x to the 9th times the x to the 8th. Because they're like bases, we add those exponents. So what's 100 times -4? That's -400. And x to the 9th times x to the 8th, we add those exponents, we get x to the 17th. Here, we have two more monomials that we're multiplying together. Again, we multiply the coefficients out front, so -3 times 15. And then we add the exponents of the like bases. So j to the 4th times j to the 9th, we add together the 4 and the 9, we get 13. K to the -2nd times k to the 7th, we add together the -2 and the 7, and we end up getting 5. So that's how you end up with -45, j to the 13th, k to the 5th. Part C, we have 3 monomials we're multiplying together. It works the exact same way. We're going to multiply together the coefficients out front first. Then we're going to multiply each of the like bases and add the exponents together of those like bases. So 7 times this invisible 1 that's out here times this 2. That goes in front. And then a to the 2nd times a to the 5th times a to the 3rd. We're going to add those exponents together. 2 plus 5 gives you 7 plus 3 gives you 10. And then b to the -6th times b to the 2nd, what's -6 plus 2? That's -4. So I get 14, a to the 10th, b to the -4th. Now, since we're simplifying this, we can't have our answer have a negative exponent. So we go ahead and take this, move it to the denominator, where it becomes a positive exponent. So we get 14, a to the 10th over b to the 4th.
What do penguins wear on their heads? Ice caps! You try.
Okay, doing the same thing here. So again, we want to multiply the coefficients that are out front. So 3 times 8 is going to give you 24. And then q to the 2nd times q to the 5th, we add those exponents together because they're like bases, and we get q to the 7th. Here, 6 times -2, we put that out front. And then x to the -3rd times x to the 2nd, we add those exponents together, you get x to the -1st. And then y to the 2nd times y to the 1st, we add those exponents together, you get y to the 3rd. Now again, we're simplifying this. We can't have a negative exponent in our answer, so we take the x to the -1st, move it to the denominator where it gets a positive exponent, and you can just write it as x instead of x to the 1st power. Next, multiplying 3 monomials together works the exact same way. What's -12 times -4 times this 1? Well, that goes out front, and that's going to be 48. M to the 1st times m to the 2nd times m to the -1st power. We're going to add those exponents together. And then n to the 7th times n to the 1st times n to the -5th. We're going to add those exponents together. So again, out front we have positive 48 because a negative times a negative gives you a positive. Here, if we add the exponents of the m's together, we end up getting 2. And if we add the exponents of the n's together, 7 plus 1 is 8, plus -5 is 3. So this is our answer. Now let's talk about multiplying monomials and polynomials. So when multiplying a monomial and a polynomial, you're just going to distribute the monomial to each term in the polynomial. So we know the distributive property. If you have something multiplied out front of a polynomial, you just need to distribute it to each term and then do exactly what we were doing. So 3x times the quantity 12x squared minus 4y squared we multiply the 3x to the 12x squared and the 3x to the 4y squared. You then multiply, just like we were doing, the coefficients out front, and then when multiplying like bases, you can add the exponents together. So this is how that works. Again, over here, when you multiply the -3 times 4, you get -12. X to the first times y to the second. Please don't add those exponents together. These are not like bases. This is the x, this is the y. So you just leave it x to the first, y to the second. Example 2, we're multiplying a monomial, or a constant in this case, to this binomial. So again, we just use the distributive property. We're going to multiply the 9 to the 2x squared and the 9 to the -5x. Now, all we have to do is simplify like we were doing. What's 9 times 2x squared? Well, you multiply the 9 and the 2 out front. And then -9 times this 5, we end up getting -45. Since 9 is a constant and doesn't have any variables, we don't have to worry about multiplying like bases and adding exponents. It's super easy. It's just going to be 18x squared minus 45x. For part B, we are again going to use the distributive property to take this monomial and multiply it to this binomial. So we got to multiply it to each term. So we're going to multiply the -2a squared b cubed to the 3ab squared and to the -a to the 4th b. Now, what we need to do is multiply the coefficients together. So the -2 we multiply to the 3. The like terms we also multiply together. So the a squared, we're going to multiply the a to the first. The b cubed, we're going to multiply to the b squared. Then here we multiply the -2 to the 1 that's over here, so it's just -2, and this minus is going to end up making it +2. The a squared, we multiply to the a to the 4th, right? We're going to add those exponents together, and the b cubed, we multiply to the b to the 1st. Now, let's simplify this. -2 times 3 is going to give you -6. A to the 2nd times a to the 1st, we add those exponents together, we get a to the 3rd. B to the 3rd times b to the 2nd, add those exponents together, we get b to the 5th. Now, minus -2 ends up becoming plus +2, so it's going to be +2. A to the, add the 2 and the 4, we get 6th power, and then b to the, add the 3 and the 1, we get 4th power. And you're done.
What do you see on a happy penguin's face? A penguin! You try.
So again, we're going to use the distributive property. We're going to take this 8p and multiply it to the p squared, and take the 8p and multiply it to the -4q. So what ends up happening here, we're going to multiply the 8p and the p squared together, and when you multiply two monomials, you multiply the coefficients together out front, so 8 times this invisible 1, and the p to the first times the p squared. Over here, we take the minus and then multiply the 8 and the 4 together. Then we multiply the p to the first and the q to the first. So 8 is the only constant here, so it's just going to be 8, and then p to the first times p to the second. When you multiply like bases, you add the exponents, so that becomes p to the third. Over here, the 8 and the 4 multiply together to get 32. The p to the first and the q to the first, those are not like bases, so we don't add the exponents together. We just leave it p times q, and you're done. For part B, we're again going to distribute this monomial to each of the terms. So we take -5x to the 4th y, multiply it to the -7x, and multiply it to the 6x squared y cubed. Now we just need to simplify each of these multiplications. So here, we multiply the -5 to the -7 out front. We multiply the x to the 4th times the x to the 1st, and the y to the, well, there's no other y, so we just tack that on the end. Plus, and then we have -5 times the 6. Then we multiply the x to the 4th times the x to the 2nd. Then we multiply the y to the 1st times y to the 3rd. So now let's go ahead and simplify this. What's -5 times -7? That's going to be +35. Then x to the 4th times x to the 1st is going to be x to the, we add those exponents together, 5th power, and then y to the 1st we tack on the end, so it looks something like this. Over here, -5 times 6 is going to give you -30. We then multiply the x to the 4th times the x to the 2nd, and you get, when you add those exponents together, x to the 6th, and the y to the 1st times the y to the 3rd. When you add those exponents together, you get y to the 4th. Again, the reason that we're allowed to rearrange the specific places of this as we're multiplying it, it's the commutative property of multiplication. If it's all multiplication, it doesn't matter which order you multiply it in, okay? So we rearrange it so it makes the most sense. That's why we multiply it like this, where we see the numbers out front, the coefficients multiply together, the x's multiply together, and then the y's. It helps you figure out what you need to combine. Example 3, we're going to take this monomial up front and distribute it to each of the terms just like we were doing. The only difference is it's no longer a binomial that we're multiplying our monomial to, it's a trinomial. So we distribute it to each of the terms just like you would. So we take 4a squared, we multiply it to the a to the third. We take 4a squared and we multiply it to the 7a. We take the 4a squared and multiply it to the negative 8. Now simplify each of these. So we take 4a squared, and when we multiply it by a to the third, we're going to end up adding these exponents together. Here, we multiply the 4 and the 7 and the a to the second and the a to the first. Again, using the commutative property of multiplication, we can rearrange these, and we know that we have to add these exponents together because they're like bases. And then lastly, we multiply the negative 4 and the 8. When we simplify this, this becomes 4a to the fifth. Because these are like bases, we add the exponents. This becomes 28a to the third, and this becomes 32a to the second, and you're done. Here, we have t squared times the quantity 3t plus 1 minus t times the quantity 8t squared minus 1. Here, we actually have a monomial multiplied by a binomial, and then minus a monomial multiplied by a binomial. So we're going to have to distribute twice here. So we're going to distribute the t squared to the 3t and the 1. Then we're going to distribute the negative t to the 8t squared and the negative 1. Now notice, when I distribute the negative t to the negative 1, we get positive t plus 1. Now what we do is we simplify each of these terms. So t squared times 3t, t to the second times t to the first, right? We're going to rearrange this so the number comes out front, our coefficient, and then the t squared and the t are next to each other. So we see that we have to add those exponents together. Here, again, we take the coefficient, move it out front. Here, take the coefficient, move it out front. That way we see that when we multiply the t to the first and the t to the second, we're going to add those exponents together, and then we have another t to the first over here. So let's simplify this. This becomes 3t to the third, this becomes just t to the second, or 1t to the second, and this becomes minus 8t to the third. Lastly, we get t to the first, or just t. Now, are we done? No, we can actually simplify this further. 3t to the third we can combine with the negative 8t to the third, because those are like terms, and get negative 5t cubed. That comes first because it has the greatest degree. So in standard form, this would come first.
What's a penguin's favorite school activity? Snow and tell! You try.
Okay, again, we're going to take this monomial up front and distribute it to each of the terms in the trinomial. So I'm going to take this negative y cubed and multiply it to the 7y squared. I'm going to take the negative y cubed and multiply it to the negative 4y. And then I'm going to take this negative y cubed and multiply it to the negative 1. Notice that when I have a negative times a negative, those turn positive. Here, I now am going to rearrange this using the commutative property. I can take the negative 9, move it out front to multiply it with the 7, and I end up getting negative 9 times 7, which is negative 63. That's going to be out front. Same thing here. I move the 9 and the 4 out front, and that ends up giving me 36. And then I move the 1 and the 9. That just gives me 9. Now the y's are next to each other, so when I multiply these two together, I can actually add those exponents. That becomes y to the fifth power. Over here, y to the third times y to the first gives me y to the fourth, and then y cubed is just y cubed. And then you're done. Here, just like last time, we have a monomial times binomial and a monomial times binomial. So we have to distribute for both of those. We're going to take this 4b squared and distribute it to the b to the fifth and to the 6b. Over here, we're going to take this negative 2b and distribute it to the negative 6b cubed and to the 5b. Notice that when I multiply negative 2b to the negative 6b cubed, the negative times the negative make it a positive. Now we're going to use the commutative property to rearrange these and make it so we can see what we need to combine. This 4b squared b to the fifth, that's already ready to go. The 4 and the 6 we're going to move out front, and then the b squared and the b we put next to each other. The 2 and the 6 we put next to each other, and the b cubed and the b we put next to each other. And then over here, the negative 2 and the 5 we move out front, and then the b to the first and the b to the second we put next to each other. Here, b squared times b to the fifth, we add those exponents, we get b to the seventh. Here, b squared times b to the first, we add those exponents, we get b to the third. B to the first times b to the third, we get b to the fourth, and then b to the first times b to the second, we get b to the third. Now, are we done? Is there anything else we can simplify here? Yeah, we actually have two like terms. We have this 24b cubed and this negative 10b cubed. So what is 24b cubed minus 10b cubed? That's going to be 14b cubed. If I want to write this in standard form, we go with the highest degree first, so 4b to the seventh, and then we'll go plus 12b to the fourth, and then plus 14b cubed, and you're done. Now, a word problem. It says a circular mirror is surrounded by a rectangular metal frame. The radius of the mirror is 5x inches. The base of the metal frame is 25x minus 3 inches. And the height is 4x squared inches. What is the area of the metal frame. Write your answer in simplest form. Here's how we do this. We first, in a word problem, tell ourselves we're not scared, we can do this. So step 2. We're going to define our variables. In this problem, what do we got? Well, we know that the radius of the mirror is 5x inches. So if we have our figure here with our circular mirror that's surrounded by a rectangular metal frame, we know that the radius is 5x inches. So one of our variables is going to be the radius. So we'll say r is the radius of the circle. Now, anytime you can draw a diagram and label it, please do. It'll help you solve it. So the radius of the mirror is 5x inches. So we go for our circle here and we make the radius 5x inches. Next, it says the base of the metal frame is 25x minus 3 inches. So the base is going to be another variable. So we say b is the base of the rectangle, and we label that over here 25x minus 3 inches. Lastly, the height is 4x squared inches. So h is going to be another variable, and over here we label 4x squared inches as our height. Now, what are we going to do? Well, it says, what is the area of the metal frame? So that would be this dark gray part here. Okay, so in order to figure out the area of the metal frame, what we have to do is we have to take whatever the area of the circle is and subtract it from the area of the rectangle. So the area of our frame, this dark gray part, is going to be equal to whatever the area of the rectangle is minus the area of the circle. Now all we have to do is just plug in what we know. We know that the base is 25x minus 3 inches, so that goes in for b. We know the height is 4x squared inches. That goes in for our h, and then we know our radius is 5x, so that goes in for r. Now we simplify. Over here, if I were to multiply these two things together, well, I have to actually distribute the 4x squared to the 25x and to the negative 3. Over here, the 5x, I have to square. And when I square 5x, I square the 5 and the x. So it looks something like this. Now, when I multiply the 4x squared and the 25x, 25 times 4 gives me 100, and then x to the first times x to the second gives me x to the third. Then here, negative 3 times 4 gives me negative 12, and over here we said this is going to be 25, then times pi and x squared. Now, technically, these two are like terms in that they have the same variable to the same degree, but this one has a pi, so we're not going to actually add these together out front. We're just going to leave it like this. So we're going to say that our answer, because we were asked a word problem, we answer in the form of a sentence. The area of the frame is 100x cubed minus 12x squared minus 25 pi x squared inches squared. Remember, it's square inches because it's area that we're dealing with.